Allen Bradley vs. Siemens ladder logic, key differences. Same logic, two completely different looking programs. If you've only ever worked one platform and you walk up to the other, the ladder can look almost unrecognizable at first, even though the underlying idea is identical. I've worked both across 25 years in this field. Let's go through exactly what's different. First difference you'll hit immediately: instruction naming. A normally open contact is XIC in Allen Bradley, examine if closed, but the same symbol in Siemens is just called a normally open contact, no special mnemonic, you just place it. An output coil is OTE in Allen Bradley, output energize. In Siemens, it's simply a coil, sometimes shown as an assignment box. Timers follow the same pattern. Allen Bradley uses TON, TOF, RTO as distinct instruction blocks with their own preset and accumulator structure. Siemens groups timer functions differently: S_ODT, S_OFFDT in older Step 7, or IEC timer function blocks like TON and TOF in TIA Portal, which actually converged closer to the Allen Bradley naming in recent versions. Point is, the concept transfers directly, only the label and sometimes the exact parameter structure changes. Second big difference, and this one trips up a lot of technicians moving between platforms: addressing philosophy. Allen Bradley has been tag-based for a long time. You create a tag with a real name, like Conva1 running, and that name is what you see throughout the whole program. No memorizing raw addresses. Classic Siemens Step 7, the older platform still running on a lot of existing plant equipment, uses absolute addressing: I0.3 for a physical input, Q0.1 for an output, M10.1 for an internal memory bit. You can attach a symbol table with friendly names, but the underlying address is always there and often what technicians actually reference when troubleshooting. Newer Siemens TIA Portal moved toward tag-based addressing similar to Allen Bradley, but you'll still find plenty of I and Q and M address references in the field, especially on older Siemens installations, because that convention runs deep in how Siemens technicians were trained for decades. Structurally, Allen Bradley organizes a program as a continuous list of numbered rungs inside a routine. Siemens organizes logic into networks inside a block, an organization block, function, or function block, and each network is its own visually separated segment, almost like its own mini-rung with a title and comment area built in by default. Functionally they do the same job, a container for one piece of logic, but the visual layout and file structure feel different enough that jumping platforms takes a bit of reorientation, even for an experienced programmer. Zooming out further, how the whole program is organized. Allen Bradley structures a project into programs containing routines. You might have a main routine, a motor control routine, a fault handling routine, called from main. Siemens structures a project into blocks with specific types. Organization blocks, or OBs, are the entry points, OB1 being the main cyclic program. Function blocks, FBs, hold reusable logic with their own memory. Functions, FCs, are reusable logic without dedicated memory. Data blocks, DBs, store data separately from the logic itself. It's a more formalized separation between logic and data than Allen Bradley's routine structure, which mixes tags and logic more freely within a program. So which should you actually learn? Honestly, whichever one is running at your plant. The core ladder logic concepts we've covered across this whole series: contacts, coils, timers, counters, interlocking, transfer completely between platforms. What changes is the syntax, the addressing convention, and the software environment around it. If you're starting from zero with no plant preference yet, Allen Bradley's tag-based system and continuous rung numbering tends to be a slightly gentler entry point for beginners. But if your plant runs Siemens, learn Siemens first. There's no substitute for being fluent in what's actually installed where you work. And honestly, once you're solid on one platform, picking up the second is far faster than learning the first, because you're translating syntax onto concepts you already understand. Quick recap. Instruction naming differs: XIC and OTE versus plain contacts and coils. Addressing philosophy differs: tag-based versus address-based, though the platforms are converging. Program structure differs: routines versus organization blocks, functions, and data blocks. But underneath all of it, the ladder logic concepts are identical, and that's really the whole point of this series: learn the concepts once, and you can read almost any plant's program. Next video, we'll get into real troubleshooting, how to read a fault on the HMI and trace it backward through the actual rung causing it, the practical diagnostic skill that separates someone who can build logic from someone who can fix it fast under pressure. Subscribe so you don't miss it.